Let's say that you were asked to find the distance or the length of each line below. What would be the difference? Well, to start with the one on the left, since it's a horizontal line, you can just count how many places it hits. So from here to here, it goes a distance of 1, 2, 3, 4, 5, 6 units. So this would be 6 units apart. But for the one on the right, it's trickier because it's not a horizontal or vertical distance anymore, so we can't just count them. For example, from here to here, what would we call that? It's not 1 since it's on a diagonal. So for now, this would just have to be a question mark. In this video, we'll learn how to calculate the distance between 2 points that are on a diagonal such as this using the Pythagorean theorem. So how does the Pythagorean theorem play into this? Well, we know a Pythagorean theorem relates to the sides of a right triangle. But I don't see a triangle when I just have one diagonal line, but we can make one. In the first slide, we talked about how we can count a line and how long it is if it's vertical or horizontal. So we're going to make a right triangle by drawing a horizontal and vertical line. So if I start with my point on the left, I'm going to draw a vertical line that would go to the next point. So let's say I call this A. I would then want to count how far horizontal they are apart, which would be something like this, and I could call that B. So if I look at the right triangle I just created, that would show me that the diagonal line I'm trying to find the distance of is really the hypotenuse of that right triangle. So I can use the Pythagorean theorem of a squared plus b squared equals c squared to calculate how long that diagonal would be. For this particular example, I can count that my a value here is 3 units. So a squared would be 3 squared, which is 9. Adding together my b value, my b here would be 6 units. So I would say plus 6 squared, which is 36. And I'm going to set that equal to the value I'm trying to find, or my c squared. So if I calculate that, 36 plus 9 would give me a value of 45 equal to c squared. Remember, to get c by itself, I would have to square root both sides. It doesn't give me a whole number by any means, but it's 6.708. So I'd want to check my rounding instructions. Let's say I was wanting to go to the 10th place. My final answer would be 6.7. If I wanted to go to the 100th place, my final answer would be 6.71 units. In a similar example, it says find the distance between point A and point B. The difference is I don't have that line drawn in, but it's essentially the same question. So if I wanted to, what I'm really looking for, the distance between A and B would be this line here, which I'm going to call C. In the last example, I started by drawing my vertical line, but it doesn't matter. Remember, your A and B can be interchanged. So let's say for this one, my gut tells me, well, I want to look at this distance first. And I can call that A, and here it looks like it's a unit of 4. Then I can look at my vertical distance here, and let's say I call that B. Remember, it doesn't matter which one's which. And I see that this one is 5 units long. So the Pythagorean theorem of a squared plus b squared equals c squared. I'm going to plug in the values that I have for this example. I said my a value was 4, so I would do 4 squared, which is 16, plus my b value squared, which here is 5, and 5 squared is 25. And all of that is going to be equal to c squared. So 16 plus 25 gets me 41. So 41 is equal to c squared. So if I square root both sides, I get 6.403, so let's round to the 10th place. And the distance between A and B here, represented by C in my picture, would be 6.4 units. In this last example we're going to look at, the only difference is instead of actually giving you the visual of those points, they just told you what the points were. So it says find the distance between points -6, 1 and -4, 5. I'm a visual person myself, so I'm going to take just a scrap of graph paper and help me to see these points. Remember, a point is listed as x, y. So to graph negative 6, 1, I'm going to come to the left 6 units and up 1. That would be my first point. And then for the next one, I'm going to go left 4 and up 5. And that would be my second point. So again, the distance between those would be my C value in my right triangle. Here, my A value would be 2 units. And then my B value here would be 4 units. So in A squared, I would have 2 squared, which is 4. For B squared, I have 4 squared, which is 16. And all of that is going to be equal to C squared, which I don't know yet. So 4 plus 16 is 20. So 20 would be equal to C squared. Taking the square root of all of that, I get something close to 4.47 units. Even if you didn't have nice graph paper like that, you could still kind of make your own on a scratch piece of paper just to give you that idea of how far apart they would be. I think it's easier if you can see them. So in summary, whether you have the graph or you're just given those 2 points, create your own right triangle by thinking about how far apart vertically would those be and how far apart horizontally those would be. Those are going to be your A and B values, and that distance between the 2 points would be your diagonal, which is always going to be the hypotenuse or C. Good luck!